Thank you very much. Thanks for the intro. And thanks for inviting me here. I really appreciate the chance to talk about this and put this together. I'm a little bit sort of after what happens. So after the outbreak, and that's kind of where I'm going here. And what do we expect in the future for these sites? Get this to work. There we go. Thank you. And all of these insect infestations and different disturbances are actually happening in a context. And the context is that we are actually dominated by intermediate age forests now. And that's very different. And so sort of picking up from the theme of last night, this is not your father's forest. This is a different forest now. And you can see that throughout the Northeast. It's actually intermediate age forests, and that's different from mostly highly managed forests in the South, old forests in the West, and some managed forests here. So these impacts are happening within the context of past agricultural abandonment, intensive forestry by us, intensive forestry, intensive charcoaling, and now most of our stands are somewhere between 70, 120-year-old stands. And that is a different sort of situation. At the same time, these forests are faced with a very large number of threats. And this is from a recent paper by Gary Levitt et al., looking at just countywide counts of invasive forest insects and pathogens. And we're sort of ground zero here. So these two sort of factors are really kind of driving, I think, what we're seeing throughout the Northeast. The one I really want to focus on today is southern pine beetle in southern New Jersey. And you can see sort of the spread here. This is 2002 shown in dark. This is from a really nice paper by Aaron Weed and the Dartmouth crew. And then in 2010, how far it spread. These actually aren't to size, but some of these are actually a majority of them are larger than 6 hectares. So these are large spots. And what's happened, here's an aerial view of one, very similar to what John showed, right at the sort of initial infestation. This is the feeding front, or the mortality front, coming at us here. Southern pine beetle is still certainly there, so we're seeing some recent outbreaks. Not quite the density that we did, but it's still there. And I think we're just, it's under the right conditions, we'll see much more of this. And so what I was really interested in is, so what's happening? What occurs within these stands? This tree's dead right here, this large pine right here. These are dead pines that have already fallen. And this is a gap that we were working in a couple of years ago in the Tuckahoe Wildlife Management Area. And it really struck us is that we didn't really have particularly good census data as to what was the structure after these outbreaks and after the various treatments. So my questions here are, one, how is southern pine beetle and the associated treatments, and I'll go through the treatments in a sec here, altering forest structure and composition of these intermediate age forests? And I'm sort of thinking about the future. So where are these stands going in the future? Secondly, how are they altering hazardous fuel loading and stand microclimate? Are these more or less flammable? What sort of loading would we expect, and what do we expect in the future in these stands? And thirdly, I'm just going to touch on this one, but how do they affect forest functioning and the capacity of these forests to respond to future disturbances? And of course, I want to think about climate drivers here too, so that there's definitely a sort of view to the future is what I'm trying to get at here. The treatments that we sampled were natural. That's no treatment. So the spot came in, the trees died, but there was no harvesting or no sort of treatment that occurred. Cut and leave, like John said, that's where trees were cut and just left on the ground. we had a third treatment, cut and chip, where the trees were harvested and they were bunched and then they were chipped, but because there was so little of a market in New Jersey, they pretty much just stayed on site, or maybe they sold some of the chips, or in some, even the chips were just spread out all over the landscape. So sort of a different situation in the South, or in a lot of other areas where there's active a timber market where you could actually sell those trees. Very few trees were sold in New Jersey. And that affected, of course, the ability to conduct these because it was all for no profit, loss. What we did was we sampled trees, saplings, seedlings, and cover data were collected in paired plots. So adjacent to each of these treatments was an unaffected area. And so we always tried to pair the sampling. And we used primarily FIA, forest inventory and analysis, sort of standard Forest Service techniques. But we also tracked cover by species cover. We were really cognizant of the species, trying to see if there were any species changes. In 55 stands, and this was actually really fun over 2 summers. I sampled every single one of these stands with a crew, and I think we got a lot of work done. It was good. There we go. This just shows sort of an example of what these stands would look like. This is in 2011, right as this stand is getting affected. And you can see these spots are starting to coalesce. This is what it, whoops. Jump ahead there. Oh, come on. To the, oh, there we go. It is a touchy clicker. Here we go. Sorry about that. And this is what happened. This is what happened right about the time we sampled this stand in June 2015. And you can see right here, there's a beginning of a cut and chip set up right here. Here's all the trees that they harvested off, and then a very large natural stand. The control stand was in here. So we tried to sample pairs like that. Another example is here in Millville, where this is all quite dense pine forest in here. Then by 2015, you can see a very large, almost clear cut, where they've harvested all the dead pines out, left these like skid roads in here, and then here's essentially the loading deck right here. Another large one over here, a natural stand in here. So some of these were actually quite large operations, very much like large clear cuts, really, where they would take all the pines out. So it was almost like a selective cut. First off, I wanted to look at some data here. So how are these treatments affecting forest composition and structure of these stands? Well, one thing that's happening is there's very high pine mortality, of course, and it's mostly trees. And so on average, in those 55 stands, we've gone with the 90% mortality of the large trees, we've gone from about 80 tons per hectare down to about 10, less than 10 tons per hectare of seedlings and saplings. In the natural stands, the saplings are still there. So they didn't really get killed, but in the treatments, sort of all the pines go, which is unfortunate because that's affecting the future regeneration of the pines in these stands. The next thing we wanted to look at, I've switched over to basal area here, and I've just noted there's that sort of critical basal area that John was getting at, but expressed as meters squared per hectare of basal area. And so all the stands that we sampled were above that. So, the southern pine beetle definitely got into those stands. And then this is as basal area. So with live trees on top, a very low number of pines in natural and cut and leave, and then very little in cut and chip. So cut and chip took all the trees out with these more intense timber operations. But it left all the oaks in the upland sites and all the hardwoods in the lowland sites. And that would mostly be red maple, black gum, sweet gum, things like that in our lowland sites. And so basically, oak trees and hardwoods are unaffected in these stands, both in natural and in the treatments. In the saplings, basically the same situation. Here's the basal area of pine saplings, which is a good thing in the natural stands, but again, showing that in very large reduction of basal area of pine saplings, and then the same thing. And so, overall, these stands are going to hardwood stands. I mean, it is going to be very difficult without doing something to regenerate pines, at least in these treated stands. And so that is going to be a challenge for the future, I think, in treated or heavily treated stands like we've seen. We've also wanted to of course, we looked at understory cover as to what was happening. And as the canopy is reduced, there's probably a small increase in the understory cover, but it's already pretty high. And these are a lot of shrubs, a lot of ericaceous shrubs in these understory stands, much like here. In the lowland stands, there's sweet pepperbush, clethra. There's a number of other. There's some of the wetter ferns are in these stands, and highbush blueberry, things like that. So these are already really dense understory stands. Oops. There we go. Okay, let me move on to my second question, and that is, how are they altering hazardous fuel loading and stand microclimate? And sort of what would we expect? And honestly, what we thought was going to happen in these stands before we got into them was that there was going to be a very large amount of regeneration of young pines. And we were going back to the late 1800s stand structures where we were going to see basically high wildfire risk in very young, very dense pine canopies. And that's not what we saw. So here's the reduction. Well, first off, here's the reduction in the crown fuels, and that just follows the reduction in pine. So we calculated this out as available fuels from a lot of harvest data that we'd done, much like Matt Duvenek had done in the past. So we had really nice allometric equations for basically needles, twigs, and some of the small live stems. So we could calculate sort of crown fuels. A few things happen here. One is that red needle phase is really short. And so impacted pines that are dying drop those needles actually quite rapidly. And if you think about it, that red needle phase is just a wildfire nightmare, because if you have that much dry fuel in a dense pine canopy, that's a pretty horrendous fuel situation, but it's a very short-lived situation. And then, much as John had mentioned, these pines start actually pretty much falling apart pretty quickly, and they're dropping the smaller twigs. And so basically by the time we were there, just a couple years after some of these impacts, there's basically no crown fuels left from the pines. And then, of course, with the treatments, there's very few. Some from the understory. Here is, I can get it to go. Oops. It is tricky clicker. There we go. This is the pine regeneration, and what I've done is I've plotted, this time by the 3 treatments, so natural, cut and leave, cut and chip, the number of pine seedlings by meter, well, by basically decimeter height classes. And we saw actually very low number of seedlings in the natural and the cut and leave stands, more in the cut and chip, and it was really where they're most disturbed, where you have that bare soil. That's where we're starting to see some regeneration. The problem here is, if this is a survivorship curve, which it isn't, but if this reflects actual survivorship of these pines, of the pine seedlings, there's very low regeneration. And this is certainly not a hazardous situation where you'd have, on the order of tens of thousands of new pines coming in. So it's not going to what we had talked about a little bit earlier, and some last night, were these dog hair pine canopies where you had very dense pitch pine. That is, we're not seeing that, at least in the stands we've sampled. Oops. What about microclimate? And we've actually been doing this in both gypsy moth and in southern pine beetle stands, but just trying to quantify what's happening with overall microclimate. And since these are weather-driven fires in a lot of these situations, and sort of overall what we're seeing is just greater extremes in air temperature and relative humidity. It's hotter in the day, but sometimes cooler at night. It's definitely windier in these opened up areas compared to areas with canopy. So we're seeing greater turbulence, greater wind gusts. We're also seeing higher precipitation inputs. There's no interception loss. So as rainfall falls on a canopy, a lot of a poor proportion of it evaporates back out before it gets to the soil. Well, that doesn't occur if there's not much of a canopy there. But what we're seeing is an overall greater sort of fire weather dynamics occurring in these. And as this changes, and you can see what's happening in this gypsy moth situation, there is pine regeneration here, and that's kind of where I'm going next here. So in these treated plots, is this the end of the line for pines? Well, no, because there are other defoliators on the landscape. And so, again, this is where sort of these interacting disturbances in these intermediate age forests are really something that I think we need to think about, that it's a bit of a brave new world out there. Because what we're seeing, maybe, this is what happened in New Jersey in 2007. We had a large outbreak year, 2005 to 2008, but the acreage here of heavily damaged gypsy moth in primarily oak dominated, but also in mixed forest, and a little bit in pine dominated, where they just basically defoliated the understory, averaged about 20 to 25% of the overall area of these forests. And in the oak stands, it drove significant pine mortality. And so within that, we've had some long-term plots that we've been sampling before the defoliation by gypsy moth, and have continued that sampling. And the one I'm going to talk about primarily is right here at the oak-dominated forest, right at the experimental forest. Maybe. You can do it. Oh. We went right to the end of the talk. Oh, let's see what happened here. There we go. Here's the oak mortality right here. So we were heavily defoliated in 7. Mortality really kicked in after 2009, so it took a couple years to really reduce the large oak trees as they died. But look at what's happening with pine saplings here. So the basal area of pine saplings, and these are released seedlings. Some are new seedlings, and some are released seedlings going to saplings. So that it's not over yet, but again, it may involve other disturbance factors other than fire. And so, and these are, if you go back and look at sort of the maybe, you guys have a challenging clicker here. Oops. If you look at these areas, the overall area that's impacted here, this is much larger than the amount of area that Tommy's burning every year. And it certainly surpasses the amount of wildfire area. And so I think when we think about managing these stands and think about sort of where we're going with overall stand management here in Long Island, to be cognizant of these other drivers that are occurring, that are really changing the disturbance environment here. Okay, we've been trying to sort of think about this. So where are we going? Where are we going in the future here? Maybe what we would think about in the past is with no fire, we would have primarily pine or oak-dominated stands here, but gypsy moth can get into these stands and other drivers, cause overstory oak mortality, a pulse of pine regeneration. The overall effect is to deaccelerate succession here, and that's ending up with mixed composition, uneven age stands. In the pine situation up here with fire, right here, so fire is allowing the pine stands to actually continue to propagate on the landscape, but then things like southern pine beetle, pine looper are strongly driving overstory pine mortality, and that's allowing oak regeneration, hardwood regeneration, depending on where you are on the landscape of uplands and lowlands, and accelerating succession. But again, where we're going is here, is mixed composition, uneven age stands, and maybe a little bit like what's here in Long Island, and certainly in a lot of the New Jersey area. The question is, so now what happens to these stands in the future? Are these more resistant to insect damage? And they may be, because at least for southern pine beetle, those mixed stands, the pines in those mixed stands are below that critical basal area for infestations. With lower gypsy moth, there's lower oak density, but there's also a change in the, and I didn't really get into this, but there's a bit of a change in the nitrogen content of the foliage. So there's a lot of changes that are happening in these stands, and if we can sort of be cognizant about managing within this context, I think we may be more successful in what we're trying to achieve out there. So overall, to conclude here is that pine-dominated stands and the recent range extension is causing significant pine tree mortality in these stands, and certainly in the future favoring oaks and upland stands and the other hardwoods in these lowland stands. It looks like wildfire risk is actually reduced after that red needle phase, so that there's just not fuels out there. And then the coarse wood that's on the ground, that's not really going to burn in these, in western fires maybe, but I don't think so, not in relatively fast-moving fires here. But maybe gypsy moth is going to save us here, because with the differential mortality driven by gypsy moth, that is favoring the release and regeneration of pine seedlings. And so pines are certainly not eliminated from the landscape, but maybe they're changing positions here on the landscape. Both of these major disturbances seem to be favoring the formation and persistence of mixed composition stands on the coastal plain. So the challenge is going to be, where are these going? How do we manage these kind of stands? Kathy, I put a slide in here for you. And that is, you asked me about functioning, or we talked a little bit about functioning of these stands. Well, we've actually had eddy covariance towers in all these stands. We've been measuring carbon dioxide flux here. Whoops. And I just wanted to say one thing, maybe, whoops, maybe not, is that it's really all this mortality is impacting the capacity of these stands to actually sequester carbon and their overall productivity. They're actually as productive, so that gross primary productivity recovers very quickly. But now, all of a sudden, with all this coarse woody debris and all this detritus on the forest floor, the respiration signal is much greater, and that's actually causing a lower rate of CO2 uptake. And at the oak stand that we've been studying, it's been on a decadal scale. So it's taken a decade at least for that carbon to work its way through the system. And so there are going to be some other changes here with forest floor, with litter, things like that. And so we're really sort of, it's hard to kind of wrap our heads around the amount of dynamics that are happening here. But I think we can do it. Thank you. You know, that's a great question. They did for a little while, but and this also happened with the oak foliage that fell is that when those needles fell, they had much higher nutrient content than normal litter fall, and so they actually decomposed much more rapidly than normal litter that would, say, fall in, like through the late fall and early winter months. That basically the nitrogen content was over twice what it was, and a lot of decomposition is driven by nitrogen and phosphorus content of that litter. That, a lot of times that'll drive how fast things decompose. And so I thought that was going to happen, but we saw actually not a lot of surface fuels in these stands 1 or 2 years after that had fallen. Immediately, probably, but these decomposition rates. The other thing that's happened is these stands are opened up now, and it's actually warmer and wetter, and that's driving higher decomposition rates. That's a great question, though, but I think that's what was occurring. Oh, I better cut it off.